In Lesson 1-3, you'll learn to translate verbal expressions into algebraic expressions and equations, and vice versa, and solve equations using the properties of equality. How can you find the most effective level of intensity for your workout? When exercising, one goal is to find the best level of intensity as a percent of your maximum heart rate. To find the intensity level, multiply 6p, your 10-second pulse count. Then divide the difference by 220 and your age, A. Write an algebraic expression to represent 3 more than a number. More than implies adding. So if we let our number be x, we like x. So 3 more than x would be x plus 3. Write an algebraic expression to represent 6 times the cube is to the 3rd power of a number. So 6 times, we put the 6 right in front of it, the cube of a number. So 6x cubed would be one variable expression we could write. Okay, this is moving a lot faster than we did in earlier courses. Now they want us to write an algebraic expression to represent the square of a number. So that would be squared, the exponent is 2, decreased by, decrease would be subtracting. The product is the answer when we multiply. The product of 5 and the same number. Okay, so the square of a number decreased by the product of 5 and the same number. When we want to multiply a number by a variable, we just put them right next to each other. Okay, write an algebraic expression to represent twice is when we're multiplying by 2, the difference is the answer when we subtract, of a number and 6. So first we need the difference of the number and 6, and then we want twice that whole quantity, so we need to use parentheses this time. A mathematical sentence containing one or more variables is called an open sentence. A mathematical sentence stating that 2 mathematical expressions are equal is called an equation. Now that's interesting, there's more than one correct answer. Write a verbal sentence to represent, I'm going to read it as it's written, 14 plus 9 equals 23. So that's one possible answer. We could also say the sum of 14 and 9 is 23. Write a verbal sentence to represent 6 equals negative 5 plus x. Now, I remember from my keyboarding instructor, if a number starts a sentence, you should write it out instead of typing the number. So 6 is equal to negative 5 plus a number, because it could be any variable. But x would be fine, I'm not going to complain. Write a verbal sentence to represent 7y minus 2 equals 19. One of the ways you could write that would be 7 times a number minus 2 is 19. You could also say the product of 7 and a number decreased by 2 is equivalent to 19. Lots of right answers. Open sentences are neither true nor false until the variables have been replaced by numbers. Each replacement that results in a true sentence is called a solution of the open sentence. For the equation we've looked at so far, they're linear, so they would have one solution, but we'll get to more interesting situations later in the year. Let's quickly review our properties of equality. Reflexive property, any number is equal to itself. Symmetric property, you can switch the order, so if A equals B, B equals A. Transitive property, if A equals B and B equals C, then A equals C, it's transitioning from one to another. And substitution, if A equals B, then A may be replaced for B and B may be replaced by A. So we can put in equals for equals. Name the property illustrated by the statement, if xy equals 28 and x equals 7, then 7y equals 28. They substituted 7 in for the x. Property is substitution. Name the property illustrated by the statement a minus 2 3/100 equals a minus 2 3/100. It's exactly the same on both sides. Nothing has changed. You look in the mirror. Hopefully you see yourself. So that is reflexive property. We've also used properties of equality with addition and subtraction, multiplication, division. For any real numbers a, b, and c, if a equals b, then a plus c equals b plus c, and a minus c equals b minus c, so you can add or subtract the same number from both sides of the equation. And for any numbers a, b, and c, if a equals b, then a times c equals b times c. If c does not equal 0, a divided by c equals b divided by c. So we can multiply and divide both sides of the equation by the same number. So to solve s minus 5.48 equals 0.02, we're going to undo subtracting with addition. And we have s equals 5.5. And if this was our lower class, I'd actually line up our decimals, but I think we can handle 5.5 minus 5.48 is in fact 0.02. Our check step works, all is well. To undo times 1/2, we could multiply by the reciprocal, which is 2 over 1. So we have 36 equals 1t, and we can substitute that back into the original equation to check. So does 18 equal 1/2 times 36? And we know that of course it does. We are done. Crazy progression. We're going from one step to more than one step. Okay, so to solve this, we're going to have to use the distributive property. So I'm just copying down 53 equals 3 times y is 3y, 3 times negative 2 is negative 6. Negative 2 times 3y is negative 6y, and negative times negative, watch out for that one, is positive 2. Next I can combine my like terms. So 3y minus 6y is negative 3y, and negative 6 plus 2 is negative 4. I'm going to add 4 to both sides of the equation. And I have 57 equals negative 3y. Divide by both sides by negative 3. And I get y equals negative 19. And to check, we're going to take negative 19 and substitute it in for y into our original equation every place there was a y. Kind of squished it a little bit there. So I'm just going to copy down 53, we hope, equals 3 times negative 21 minus 2 times negative 57 minus 1. Okay, so you do this on your calculator. So 53 equals negative 63 plus, and that is a true equation, so we know it's right. Now normally, yes, again, you do all of that check step business on your calculator, but I wanted to model it for you at least once so you could see how it happens. The area of a trapezoid is 1/2 the sum of the bases times the height, where A is the area, B sub 1 is one base, and B sub 2 is the length of the other base. And H is the height of the trapezoid. Solve the formula for H. Okay, so my goal is to get H on one side of the equation by itself. So to undo times 1/2, I'm going to multiply both sides of the equation by 2. So I have 2a equals, the 1/2 and the 2 canceled out, so now all I have left is b sub 1 plus b sub 2 times h. Now my goal is to get h by itself. So all I need to do is divide both sides by that sum, because it's all together. So we have isolated the h. 2 times the area divided by the sum of the bases would give us the height. We're reviewing a lot of stuff from other courses in one lesson here. If 4g plus 5 equals 4/9, what is the value of 4g minus 2? Okay, so we already have a 4g. We want to convert that plus 5 into a minus 2. So all I need to do is subtract 7 from both sides of the equation, and I have 4g minus 2, that's what I want, equals 4 ninths minus, I went ahead and got a common denominator, 63 ninths would be negative 59 ninths, and it was multiple choice. I stuck it up out of the way there, so that was choice B. And we're going to throw in a word problem for good measure, reviewing a lot of Algebra 1 concepts today. Carl wants to replace the 5 windows in the second-story bedrooms of his home. His neighbor Will is a carpenter and has agreed to help him install them for $250. If Carl has budgeted $1,000 for the cost, what is the maximum amount he can spend on each window? So setting up an equation, the number of windows times the cost per window plus the cost for the carpenter, nice having a friendly neighbor, equals the total cost. We have a nice friendly equation to solve. We're going to subtract 250 from both sides of the equation to undo plus 250. So 5c equals 750, and divide by 5. So the maximum you can spend on each window is $150. At this point, we're looking at the outdatedness of this book because it'd be way more money than that. Verbal expressions can be translated into algebraic expressions using the language of algebra, using variables to represent unknown quantities, and we use the properties of equality to solve equations.